Okay, so today's lesson, wow, it's 2:16, huh? What we're going to talk about is exponential functions and their graphs. If it's an exponential function, the variable is in the exponent. Okay, the variable is in its exponent. Exponential form, f of x equals a b to the x. And we just looked at our journal. And this is a function. Everybody agree? This is a function. So we could say y equals a b to the x. Sure, that's the same thing, except for the fact that because it really is a function, you know, we change it from y to f of x, because it is a function. It totally is, right? Okay, Gretchen, question.
Oh, I was stretching.
Okay, now, one of the things we do also is a lot of real life problems, like for instance, you have a bank account, you put money into the bank, and it grows at, say, 6% interest, right? That's exponential also. And so its base would be a percentage. So we're going to rewrite this slightly, and we're going to put it as a percentage, okay? So we're going to have, instead, an f of x equals a times 1 plus or minus r to the, and I use t for time, okay? Plus or minus. Plus or minus. One or the other, right? When would I use plus in this example?
You're minus growing.
Oh, God, you guys are smart. And when do I use negative? If you're losing money, right? That you do not want this, right? So very good. Okay, yeah, exactly. So it's that easy. Thanks, Scott. So then, let's take a look at example 1. So graph y equals 3 times 2 to the x. Okay, by the way, first of all, you know, what do I do to make you this, okay? Never, can I scare you? Never, ever, ever, ever do this. Don't do that. Don't do that. This is not 6. Don't do that. Sorry to make it big, but it happens. I'm like, no, this is 2 to the power of x, right? This isn't 6. Does it say 6 to the x? No, it says 2 to the x and then times by 3. Got it? Don't ever do that. Dave's going to have a fit, okay? That is not 6. That's 2 to the x, okay? Everybody got that? All right, you knew that already, didn't you? You knew that. Of course you knew that, right? Okay, so, we'll keep yet? I'm working on it. All right, so if I use my calculator, one of the things I can do is plug these numbers in. I can go, okay, 3 times 2 to the 0 power, right? I'm just going to let my calculator do a lot of the work. I'm going to plug it in. I'm going to get an answer of 3. So if I have a point at 0, 3. I'm going to put that on put that on here, 0, 3. And then if I plug in 1, 3 times 2 to the power of 1, I get 6. So if I plug in 1, I get 6. I'll just let my calculator do the work. 3 times 2 to the power of 2, and I get 12. But I kind of know the pattern, don't you? I don't need my calculator anymore. What do you guys think the pattern is? I'm doubling by 2 because my base is 2 anyway, right? So if I plug in 3, I'll get 24. If I plug in 4, I'll get 48, right? Now what about negative 1? I don't know. Let's see. What do you think it is?
1.5.
Let's check it out. Now, in a minute, Ava, I'm going to have you tell them why you said 1.5, okay?
to the negative 1, 1.5. Okay, now Ava, what made you say 1.5? What did you see? What in the pattern, what did you see?
Well, I mean, you go backwards and it's not just gonna reverse, you still have it.
Perfect. You guys see how she went backwards? So if you go backwards, you're just taking half, 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 half. Good. So if we went negative 2, what's the value, the y value of negative 2? 0.75. And we could use a calculator. I mean, we could say, okay, well, gosh, Mr. Davis, I'm not that smart. I got to use my calculator. That's okay. To the negative 2 power, 0.75, right? Same thing. So let's graph this. I'm probably going to have to go by tens. 2, 4, 6, 8, 10. I got to get all the way to 48, don't I? So I might want to go 10, 20, 30, maybe 40, maybe 50, right? And I'll go by ones on my x-axis. Go 1, 2, 3. I'll go negative 1, negative 2. And if I do my graph, I'll go 0, 3, and I'll have to estimate, but about there. 1, 6, about there. 2, 12. 3, 24. I'm just guesstimating. And then 4 and 48. Okay. Negative 1 and 1.5. Again, it's just like this. And then what we find on this bottom part is where Scott was walking to the door, right? Scott can never get to the door, so this graph has to just kind of like be just right here. Now, I like the asymptote. I really like the asymptote because you're going to say it touches there. It looks like it does, doesn't it? Oh, I'm sorry. You're going to say it touches there, aren't you? But it doesn't. So when I draw my asymptote in, it's a boundary line that tells me it never touches, okay? So I'm going to draw in my asymptote. Okay, my asymptote is an invisible boundary line. My asymptote is an invisible boundary line. So I'm just going to go like this, draw it in, and there it is. So my asymptote, so I'm going to have a asymptote at y equals 0, okay? How am I doing? The asymptote's important because without it, you could accuse me of touching and saying there's a value of 0, but there is no value of 0, is there? So domain. Two things. How wide is the graph, or what x values can you have? What do you think the domain is?
All real numbers.
Yes, so domain is x is equal to all real numbers. There's my domain. My range. What's my range? What's yes, not equal to, but greater than 0. Everybody agree with that? Perfect. Doesn't equal 0 at all, but greater than 0, okay? Thumbs up so far? All right, let's turn the,
When you talk about the asymptote or whatever,
yeah.
you just have to write that yellow dotted line.
Yeah. It's an invisible boundary line, right? Because you can see it's a boundary line. We're saying don't touch 0. That's why we put it in there, okay? Okay, turn the page. Okay, now, if I use my calculator again, and I'm going to put in 0, I'm going to go 48 times 1/2 to the 0 power. I get 48. I plug in 1. I go 48 times 1/2 to the 1 power. I get a 24. And I bet you probably know the pattern, don't you? What do you think the pattern is? Yeah, because I got a 1/2 for my base. You guys agree with that? So I'm going to have a 2 and a 12, a 3 and a 6, and a 4 and a 3, okay? Okay, so you want to guess what -1 would be? 96. Does that make sense? And then -2. You want to guess? Well, I mean, we could do it, right? 48 times 1/2 to the -2 power, and I get 192, okay? So let's graph this. So I'm going to go, let's see, same thing, 10, 20, 30, 40, 50, 60. I'm probably not going to get everything on my graph, but I'll get, as many as I can. 0, 48. I'll guesstimate. That's the best I can guesstimate. 124. Maybe about there. 212. About maybe right about there. 3 and 6. 4 and 3. -1 and 96 is off my paper. So my graph's going to look something like this. And now, I have to have the asymptote because it's so hard to tell. It sure looks like, because I'm not much of an artist, right? It sure looks like a touch right there. Doesn't it look like a touch? And somebody can accuse me of having a point there, but if I put my asymptote and it says, no, it doesn't touch, right? So I want to put that asymptote in because it doesn't touch, right? I'm not a very good artist. The best I can do is put an asymptote and say, nope, 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 it doesn't touch. So I put my asymptote right there. It's my boundary line at y equals 0. There's my asymptote. All right, now, am I going too fast? Slow it down for a second.
Do we just have to write the line, or do we have to write down y equals 0 asymptote?
Well, if I asked you on a quiz, what's the equation of the asymptote, you'd have to tell me, right? Which would be y equals 0. All right, now, domain. What do you think about domain? Domain. Yes, say it louder. Yes, x equals all real numbers. Very good. And range? Yes, same thing, isn't it, right? This is exponential decay. The other was exponential growth. Okay, example 3. Let's do this one. I've got a percentage. You see that? I've got a percentage, so I want to use this formula. So I want to use my y equals a1 plus or minus r to the t power. I want to use that equation because I got a percentage. I'm going to start with 100, and it grows, right? So we're going to go y equals 100, because we start with 100. Start with 100. I've got my 100 here. Parentheses, 1 plus, because it's growth, 0.08. So we're going to change 8% to 0.08, okay? To the t. The 1 is super important, okay? I'll just give you an example of why the important, why 1 is important, okay? Just listen for a second, okay? So you go to the bank, you give them $1,000, right? 8%, right? Give them $1,000 out of your pocket, right? Give them $1,000, go back, they give you $8. You give them $1,000, go back to the bank, they give you $8. All they did was give you your interest. If you don't have your 1 in your equation, all you get is your equation. You need your original money back. That's why you have to have the 1. The 1 says give you back the original amount plus my interest, okay? All right, now, let's go ahead and finish this up. So, how many bacteria will be in one day? How many hours is that?
24.
So, let's let t equal 24 and use our calculator. Y equals 100, 1 plus 0.08 to the 24th power. 1 plus 0.08 to the 24th. I get an answer of about 634 bacteria. Okay. All right, now I know my 8th graders need to go, so let me go ahead and make sure. Ava, it's right there. Do you see it? If you want to grab the homework for those guys too. It's this one here. Okay, it's that worksheet. Okay, so grab the worksheet. I'll let you guys go. Stop recording. Stop recording.